Welcome to one and all present here. This presentation is regarding the burglar alarm system using PIR sensor and microcontroller. The need for the burglar alarm. A burglar alarm is a system designed to detect intrusions such as unauthorized entry into a building or other areas such as home or school. Burglar alarms used in residential, commercial, industrial, and military properties to protect against burglary or property damage, as well as the personal protection against intruders. Security alarm in the neighborhood show a connection with the diminished robbery. Car alarms likewise helps to protect vehicles and their contents. Prisons also use security systems for the control of the inmates. So this is the main need for the burglar alarm. Hello to one and all. This is Anjana from Mechatronics Department of Tyagaraja College of Engineering. So I'm here to give an idea on the burglar alarm with PIR sensor using 8051 microcontroller. First, getting on to the objective. The objective why we need PIR sensors usage and why we need the burglar alarm. So the PIR sensor based burglar alarm, where PIR stands for the passive infra red sensor. When an intrusion is detected, the circuit uses a PIR sensor to detect the intrusion and the LCD displays about the alarm. When there is no intrusion, the PIR sensor stays calm and the LCD does not display anything. So now coming to the components of the burglar alarm. So there are various components of the burglar alarm, but we have three major or three important components which are listed as the 8051 microcontroller, the PIR sensor, that is the passive infrared sensor, and then the LCD, which is the liquid crystal display. These are the three main components of the burglar alarm to be designed. So now we are going to get an idea on what are the various parts of the burglar alarm along with their description. So the various components of the burglar alarm. In the name itself, we get an idea that it's a burglar alarm. So we need an alarm or a buzzer to indicate us. So the first component that we are going to discuss about is the buzzer or the alarm. So the component which produces sound when any intrusion is found in the PIR sensor. When there is no intrusion, the buzzer stays quiet. So here we are using a 12-volt DC buzzer. The picture of the buzzer is represented as follows. So now the second most important part, that is the microcontroller. There are various families of microcontrollers like PIC, Atmega and so on, but here we are using the 8051 family. So this microcontroller is an open source physical computing platform based microcontroller board for developing a software environment for writing programs for the board. Here we use the 8051 and the image is displayed. So in order to know the microcontroller fully, we need to know the pin diagram of the microcontroller. So here's the pin diagram. So here we come to a basic understanding that it has a total of 32 pins and 8 pins per port, so that we have 4 ports as P0, P1, P2 and P3. So where the 40th pin acts as a supply and the 20th pin acts as a ground, pin Port 0 starts from pin number 32 to 39. Port 1 starts from pin number 1 to 8. Port 2 starts from pin number 21 to 28. And port 3 starts from pin number 10 to 17. Other than that, we have the ninth pin, which is the reset pin. And we also have the transmission and receiver end as pin number 11 and 10 of the microcontroller. We also have extal 1 and extal 2 pins. So now coming to the liquid crystal display, that is the LCD. So a liquid crystal display here we use is the 16 cross 2 liquid crystal display, which means it can display 16 characters per line and there are two such lines. So in the LCD, each character is displayed in 5 into 7 pixel matrix. The image is also displayed at the side. Here we have 3 pins, one which acts as a power and one for the ground, and pins D0 to D7 where the inputs are given in order to represent the various characters in the LCD. Now coming to the major component, which is the sensor. Here we use the passive infrared sensor, that is the PIR sensor. So the passive infrared sensors are used to detect living being movements. So PIR is a passive infrared sensor which detect the infrared rays. As all living beings with a temperature above absolute zero emits a heat energy in the form of radiations. These radiations are infrared. These are being captured by the passive infrared sensor and it gets detected, and thus we get the signal. So the PIR sensor's image is also being displayed. So in order to know the pins regarding the PIR sensor, there are total of 3 pins. The first pin is the supply pin where we give the power supply of plus 5 DC voltage, and the pin 2 is the output pin where this pin is used to collect the output signal which is collected by the PIR sensor. And then the pin 3, which is the ground pin, this pin provides the ground to the internal circuit of the PIR sensor. The various pins are being displayed of the PIR sensor. So other than this, we also use resistors and capacitors. Capacitor, we use the 33 picofarad capacitor is being used across the 2 pins of the microcontroller, Xtal1 and Xtal2. Thus we use two 33 picofarad capacitors. We also use resistors of 4.7 kiloohms and 8.2 kiloohms. The 4.7 kiloohms resistor is being used in the LCD, and the 8.2 kiloohm resistor is connected to the reset pin of the microcontroller. So this is the resistor and this is the capacitor. So as soon as there is an intruder, we get the alarm. Other than capacitor and resistor, we also use the crystal frequency, which is of 11.0592 Hz. So now let us see about the requirements in order to make this burglar alarm. So the requirements to make burglar alarm. First, we are coming to the hardware requirements where we use the PIR sensor with its price as 69 rupees, and we also use a 12-volt buzzer which costs 54 rupees, and then we use the 8051 microcontroller AT89C51 which costs 398 rupees, and we also use the LCD display, that is 16 cross 2 LCD module which costs 199 rupees. And then we use a transistor 5C148 transistor in order to connect it to the buzzer, so which costs 5 rupees. And we use 33 picofarad capacitor which costs 3 rupees. And we also use another capacitor zero point 0.1 microfarad which costs 1.65 rupees. And then we use a 4.7 kiloohm resistor which costs 0.6 rupees, and 8.2 kiloohm resistor which again costs 0.6 rupees. And then we have connecting wires as per required, and then the crystal oscillator which costs 42 rupees. So the total price of the hardware requirements is about 775 rupees. So the total price of the project is rupees 775. So now coming to the software requirements. So first we use the Keil New Vision software where we generate the code, or where we type the code in either the code can be stored in two forms, either as an ASM or an assembly file or a C program file. The file is being run debugged to check for any errors, and it's proceeded. The icon is being displayed. And then the main thing is the Proteus 8 Professional. This software helps us to know the real-time working of the hardware in the software format with respective connections made. So this is the Proteus. So now we are getting into the main part of the project, that is we are going to the code for the burglar alarm. Here I have done it with the help of the C code. So let's get into it. So the first line says that include register 51.h, where it says that the register 51.h says that it's from the 8051 family's register should be included. And then we are defining the LCD with port 3 of the microcontroller. And now we are assigning the ports and the pins for various components. So first we are registering it with PIR sensor. The S bit of the PIR sensor is being placed at the port 1 zeroth pin. So the S bit of RS, where RS stands for the register select, RW read or write, EN for enable. These three pins are from the LCD, that is the liquid crystal display. So that the register select pin is being connected to the port 2 zeroth pin of the register select, and the read or write is being connected to the port 2 first pin, and the enable is being connected to the port 2 second pin. And then we have void LCD initialization, that is INIT, and then void command is being displayed as unsigned character, and void DAT is being displayed as unsigned character. In order to have the delay in the LCD display, we have void delay and we have void string, where the input string will be given. So now first getting into the void main, we are initializing a variable in terms of a long integer, long int I, and the LCD is initialized, and the LCD string, where the first line should be represented with the alarm detector. So now we are using a while loop, where while 1, so that the loop keeps running on. So when the PIR sensor is equal to 1, that is when any intruder or when there is any interruption caused in the PIR sensor, the PIR sensor gives the input as 1. As we have only digital inputs, 0 means there is no intruder, 1 means there is an intruder. So that when the PIR sensor is equal to 1, it is given as it can give only two outputs, that is 0 and 1. When it is detected as the PIR is equal to 1, we are giving the command 0xC0, where it says that it forces the cursor to the beginning of the second line. As the first line is filled with the alarm detector, we have to go to the second line. So the LCD string which is being given is intruder is being detected. So for I is equal to 0 to I is less than or equal to 20,000 and I plus plus. Here for loop is being used in order to cause some delay. And then we have the delay. When the PIR sensor is equal to 1, the program runs and we get the LCD display as uh, intruder is being detected and the buzzer gets on, or else if not, if the PIR sensor is equal to 0, then what should we do? Then again using the command 0xC0, where it says force the cursor to the beginning of the second line, the LCD string is being null. It does not print anything, it's just being left as such. So next we are coming into the void LCD initialization. Here we use the command 0x38. That is where it says that we have to use both the lines and 5x7 matrix. And then we get the command as 0x0e, where it says display on and also the cursor should be on. And then we are giving the command as 0x06 where we have to increment the cursor after each letter is being printed. And then the next command is 0x01, that is we have to clear the screen. When it is 1, the intruder is being detected. Again the screen gets cleared when the when there is no other any detection found. So the next command is 0x80, that is force the cursor to the beginning of the first line. Again it starts from the first line. So now we are using the void command, and we are having the unsigned character A, where the LCD is equal, when the LCD is equal to A, the register select is equal to A, and the read or write is equal to 0. And then the enable is set to 1, and then a delay is caused, and again the enable is being cleared to 0. Now coming to the next part, void DAT, unsigned character B is being initialized, where the LCD is equal to B, the register select is equal to 1, read or write as such is equal to 0, and the enable pin is kept at 1, and after a delay it is being cleared. So the void LCD string, the string where we have to increment when we increment the cursor, the letters in the string should also be incremented in order to make it a word and represent it in the LCD display. That is, while string, the data from the string is being incremented. The lastly, we are coming to the delay program, where the delay caused is from I is equal to 0 to I less than 20,000, and the I is incremented. So this is regarding the code generated. So now coming to the circuit that is being developed in the Proteus. This is the model circuit that is being developed with the help of Proteus. So let's see to it. So now we are going to see the simulation in the Proteus. So first, getting into the Proteus, we'll get an idea of what is being done here. So first start, then the PIR sensor is installed in certain location. If the PIR sensor is equal to 1, buzzer is set and it rings, and the LCD prints intruder detected. When not, the buzzer does not ring and LCD does not print anything. And then finally the program is ended. So simulation is in Proteus will be shown now. Yeah, coming to the circuit. The circuit here displays the PIR sensor along with the 8051 microcontroller, the LCD display, and the buzzer. First, coming to the PIR sensor, we have a VCC pin which acts as a power supply, and a ground pin which is being grounded. We also have the output pin of the PIR sensor which is being connected to the port 1/0 pin. And then we have a test pin. As this is software oriented, we cannot make intrusions. So when 0 there is no intrusion, and when 1 intrusion is being caused. And then we have the capacitors of 33 picofarad C1 and C2, which is being connected across xtal1 and xtal2, across which we have the crystal oscillator of 11.0592 megahertz. And then along with the ninth pin, we have a capacitor C3 and a reset button or a button, and along with which we have the resistor of 8.20 kilo ohms, and then it is being grounded. Now coming to the LCD display, we have VSS, which is a power supply pin, and then the VDD pin, which is having a resistor of resistance 4.7 kilo ohm along with the power supply, and the VEE pin acts as a ground pin. So we have the RS pin, that is the register select pin, which is being connected to the port 2/0th pin. And then we also have the RW, that is read or write, which is across the port 2 first pin. And then the enable pin, which is connected across port 2 second pin. And then the inputs D0 to D7 is connected to the port 3 respectively, from port 3/0th pin to port 3 7th pin. We also have a buzzer, the buzzer which is connected from the sensor it is connected to the transistor, NPN transistor, where it is being grounded. One pin is being grounded and the other pin which reaches the buzzer, and the power supply of 5 volt is being given. So this is the outline structure of the circuit. So the various components are being displayed. First we give the programmed version, which we have done it in the Keil software, to the microcontroller, and then we also have the programmed hex file of the PIR sensor, which is being given as the input to it. So now let us start with the simulation. So we are starting the simulation, where in the LCD display, as per the code, we always have the alarm detector placed. So as the input is 0, we come to a conclusion that there is no intrusion, all is set, and the LCD is left as such. And then the buzzer is also quiet, it does not ring. So now making the intrusion to be 1. We have the command as intruder detected along with the buzzer. We have the command that intruder is being detected along with the buzzer. Thus, the buzzer rings and it acts as an alarm, thus beckoning, and it acts as a burglar alarm. Thank you. Thank you to one and all for listening to the concept patiently. So these are the credits from where credits and references from where it has been taken.